Happy Tuesday, everyone. Let's start today by thinking about something you covered in fourth grade. So I want you to find the area of this figure. Think back a long time ago in fourth grade about how you find area and choose the option. If you chose 21, you are correct. So just as a review, area is dealing with a flat two-dimensional object. So like a sheet of paper, that is a flat two-dimensional object. Fencing in a yard, it's flat. So area is the amount of surface inside that area. So you can tell in our picture down in the bottom right-hand corner, area is going to take up that entire blue part. Perimeter is on the outside, but area is on the inside. And our formula to find area is area equals length times width, but sometimes you will see it A equals L times W. And our L is normally either italicized or written in cursive, because if you just make a normal L, lowercase l, it kind of looks like a 1. So just to make sure we don't get confused. So area is a flat two-dimensional object. And I dropped something on my floor and I need to cover it up. So your job is to draw the smallest rectangular carpet you can that will help me cover up this stain, because I don't want to look at it every day. It was blue paint and I don't want to look at it. So draw the smallest rectangular carpet you can that will cover the entire stain. So looking at your stain, the carpet that you drew, this is the one that I drew around my entire stain. What is the length of your carpet? The length is how long it is, the measurement of how long it is. The length of the carpet is 9 feet. Okay? What about the width? What is the width of the smallest rectangular carpet that covers the stain? The width is going to be the other side, how wide it is, and that's going to be 6 feet. So using what we know about area, what is the smallest area, or what is the area of the smallest rectangular carpet that covers the stain? So our length is 9 feet, our width is 6 feet. So what is the area? Our area is going to be 54 or 54 square feet. Okay. So let's start talking about our new topic this week. I'm going to start with this. Alexandra is volunteering to stack boxes of soup cans at a community food bank. She stacks the boxes to form the right rectangular prism below. So she has stacked the boxes. So how many boxes is she stacking? So if we count, how many boxes is Alexandra stacking? She is stacking 12 boxes. So what are some other ways that Alexandra could stack these 12 boxes? What are some other ways that Alexandra could stack those boxes? She could stack them like this, 4 rows of 3. She could stack them like this, 3 rows of 4. She could also stack them like this, 12 rows of 2. She could stack them vertically like this, so 12 rows of 1 box each, or horizontally. So there are 6 different ways that Alexandra could stack those 12 boxes of soup. So now looking at volume. Volume deals with a solid 3-dimensional object. So think of a cube. That is 3-dimensional. Anything that is not flat, we will be able to find volume with. And in 5th grade, we just focus on rectangular prisms. So our formula for volume is length times width times height. If you notice, it is almost the exact same as area, except you're adding in the height factor because it is 3-dimensional. You will see it written as volume equals L times W times H. So we're going to watch this quick video about finding volume.
Find the volume of a cube. Side times side times side will tell you the number of times a cubic unit will be able to fit inside it.
Imagine a cube with edges of 3. Multiply 3 by 3 by 3 to see it can fit 27 units. Gotta mention that they're cubic. When finding volume, don't forget to mention the unit is a cube with 3 dimensions.
To get a rectangular prism's volume right, length times width times the height. Cubic units label 3 dimensions when we answer any volume questions.
With the dimensions 2, 3, and 6. First find the base, that's length times width. The base is 6 cubes, then multiply the height. 36 cubic units, fill it up just right. When finding volume, don't forget to mention the unit is a cube with 3 dimensions.
A solid shape made of more than one prism has a volume you can find. With this wisdom, think of each shape separately and find the volume of each individually. Then add the volumes, 9 and 1, we get 10 cubic units and this problem's done.
When finding volume, don't forget to mention the unit is a cube with
3 dimensions.
When finding volume, don't forget to mention the unit is a cube with 3 dimensions.
All right. So, looking at this prism, there are unit cubes in it that you cannot see. We can only see all of the cubes on that front facing face, the one facing towards us. So I have made that yellow. However, there are 2 more stacks of cubes with the same number behind it. And we have to remember that when we're counting these cubes, they're not just floating in thin air. We have to make sure that we count the ones that are behind it. So Carlos and Kelly are building store displays in the shape of right rectangular prisms. Right rectangular prisms just means that they have right angles. They're using cube-shaped boxes of the same size. So how many cubes are in each display? Carlos and Kelly are using the same amount. So how many cubes do they have in each display? There are 16 cubes in each display. If I count Carlos, if I'm counting vertically, I see 8 boxes. Well, I know that there have to be 8 more directly behind it, and 8 plus 8 is 16. Looking at Kelly's display, Kelly has 8 boxes in 2 vertical or in 2 horizontal lines, excuse me, and I know that there's 8 more behind it. So 8 plus 8 is 16. So what are the dimensions of each display? When I'm talking about dimensions, I'm talking about the length, the width, and the height. So Carlo's display is 2 cubes long, 2 cubes wide, and 4 cubes high. Ellie's display, on the other hand, I'm looking at the length, which is how long it is 4. The width is 2, and the height of Kelly's display is 2 as well. And if you notice, this is the commutative property in action. I can move these numbers around, but I'm still going to get the same thing. The dimension of Carlos is still going to equal 16, but the dimension of Kelly's is still going to equal 16, even though those numbers are kind of all discombobulated. All right. So for a concert, Angela is building platforms using cube-shaped blocks with an edge of 1 unit. So that just means that each one of these blocks is 1 unit. So looking at platform number 1 on the left, platform number 1 has 5 cubes. I just counted the cubes. I can see all 5. I counted all 5. Platform number 2 has 8 units. So I see 4 on the front. I know there are 4 more directly on the back. Platform number 3 has 5 units. I see all of them. I counted all of them. So it's your turn. Drag the icon, drag that green star to the platform that has the greatest number of blocks. If you chose platform number 2, you are correct. Chris is building a store display using boxes. How many boxes did Chris use to create this display? All I have to do is count. 1, 2, 3, 4, 5, 6, 7. So Chris used 7 boxes to create this display. Your turn. You can just draw the number of boxes that Chris used to build these displays. Remember, if there is more than 1 layer, make sure you note that. Make sure you count them. So how many boxes did Chris use to build these displays? All right, for the green, I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, but I know there are 3 more blocks or boxes holding up my columns. So 9 plus 3 is 12. So green has 12 boxes. Purple only has 1 column row of them, I guess. So I can count. I see all of the purple ones. So all I have to do is count. Or I could use multiplication. So there are 3 in each row, and I have 1, 2, 3, 4, 5, 6 rows. 3 times 6 is 18. And finally, the yellow one on the right. I can see all the ones on the front. there are 10 blocks on the front, and I know there have to be 10 blocks behind it as well. So 10 plus 10 gives me 20. Now, when I was thinking about this, I was thinking about the displays of cans that stores sometimes put up for holidays or different kinds of things. And I was just thinking how this volume that we're talking about can be used to figure out how many boxes of cans they use. So next time you're in the store and you see something like this, see if you can count and figure out just how many boxes of cans, how many boxes of soda that these stores use to create these displays. So, for example, if I'm looking right here at the jack-o'-lantern in the middle, I can tell that each eye takes 9 boxes. So there's at least 18 boxes for the eyes, and then I can just count the nose. 18, 19, 20, 21, 22. And then I could count even the smile or even the eyebrows and figure out how many boxes, I think those are Coca-Cola boxes, have been used to create this display.